Good evening. Today I am going to talk about design of compression members. A compression member is a structural element which is subjected predominantly to axial compressive forces. Compression members are most commonly encountered in reinforced concrete buildings as columns, sometimes as reinforced concrete walls forming part of the vertical framing system. Whether the structure is man-made or created by nature, the key element in resisting collapse under gravity load is the column in buildings and bridges, in trees and plants. Other types of compression members include truss members, that is struts, inclined members and rigid frame members. The column is representative of all types of compression members, and hence sometimes the terms column and compression member are used interchangeably. The IS code defines column as compression members the effective length of which exceeds 3 times at least lateral dimension. The term pedestal is used to describe a vertical compression member whose effective length is less than 3 times its lateral dimension. A member that is subjected simultaneously to axial compression and bending moment is sometimes referred to as beam column. Now there are many classifications based on different types of criteria. The first is based on type of reinforcement. Reinforced concrete columns may be classified in the following 3 types. The first is tied columns, which is where the mass longitudinal bars are enclosed within closely spaced lateral ties. The second is spiral columns, where the man-made longitudinal bars are enclosed within spiral reinforcement. And the third is composite columns, where the reinforcement is in the form of structural steel sections or pipes, with or without longitudinal bars. Now we'll look into different type, which is based on type of loading. Now in the same case, it can also be divided into 3 types. The first is column with axial loading, the second is column with unaxial eccentric loading, and the third is column with biaxial eccentric loading. Now the occurrence of pure axial compression in a column is due to relatively rare. Generally, flexure as accompanies axial compression due to rigid frame action, lateral loading, and actual or even eccentricities in loading. The combination of axial compression with bending moment at any column section is statically equivalent to a system consisting of the load applied with an eccentricity E with respect to the longitudinal centroidal axis of the column section. In a more general loading situation involving biaxial bending moments are applied simultaneously on the axially loaded column in 2 perpendicular directions about the major axis and minor axis of the section. This results in biaxial eccentricities. Then the columns in the reinforced concrete frame buildings in general fall into third category, that is columns with biaxial eccentricities. Now the biaxial eccentricities are particularly significant in the case of columns located in the building corners. In the case of columns located in the interior of symmetrical simple buildings, these eccentricities under gravity loads are generally of a lower order comparison with the lateral dimensions and hence sometimes completed in design calculations. In such cases, the columns are assumed to fall in the first category, where columns with axial loading. The IS code, however, ensures that the design of such columns is sufficiently conservative to enable them to be able of resisting nominal eccentricities loading. Consequently, the eccentricity about 1 is negligible where the eccentricity of 0 of the other axis is significant. This is encountered in the exterior columns of interior frames in a reinforced concrete building under gravity loads. Under lateral loads, wind or seismic, indeed all columns in a multi-story building are subjected to significant unaxial bending moments. Such columns fall into the second category, that is columns with unaxial eccentricity. Now the third classification is based on the slenderness ratio. The columns, that is compression members, may be classified into following 2 types depending on whether slenderness effects are considered insignificant or significant. Number 1 is short columns and number 2 is slender or long columns. Slenderness is a geometrical property which is related to the ratio of its effective length to its lateral dimension. The vulnerability or the failure